Thanks everyone. Today we are going to discuss about the VSPER theory, valence shell electron pair repulsive theory, which was presented by Mr. Powell and Mr. Shindwich and Mr. Powell in the year 1940. And that theory was presented on the basis of the purpose or agenda to identify and determine the shape of molecules. Determine the shape of molecules or determine the shape of the orbitals which contribute to making the shape of molecules. In that case, this was what the theory was all about, and in that theory, that include the determination of shape of molecules by the valence electron of central atoms. Why valence electron of central atoms? Because we know that the valence electron of central atom forms the hybrid orbitals, due to which valence electron of central atoms were involved in the formation of and determination of the particular shape of the molecule. As we know that these are having same valence electron uh, of the hybridized orbitals in the central atom are in the hybridized orbitals, and these hybridized orbitals are having less amount of energy, due to which they are visible. They showcase the real bond of a molecule, while the high energy bond pi bond does not showcase the energy levels of a particular bonding of molecule of an atom. So in that case, this is why valence electrons of central atoms are required, and there are three types of valence electron of central atoms. First includes the unpaired electrons. Second includes lone pairs. Third includes pi electrons. Here we know that unpaired electrons are the electrons which unpaired electrons. So here we have unpaired electrons. Unpaired electrons are the electrons which are most actively participating set of electrons. Most actively participating set of electrons in determining the shape of molecules. When it comes to lone pairs are also active set of electrons which are participating to determine the shape of molecules, but these are less actively participating set of electrons. Pi electrons are non-actively participating set of electrons, non-actively participating set of electrons. Rest when it comes to some classification on the basis of this theory, that here first and foremost we have previously discussed all about how this theory works and what are some postulates, as well as all of the points which were included, which were being told in the valence and the hybridization are quite resembled over here. That here the lone pair are having lone pair repulsion is more than lone pair bond pair repulsion, than and that is more than the lone pair repulsion. Rest, when it comes to another fact, the lone pair occupy much more surface area or space of the atom as compared to bond pair, because the electrons are not bonded; these are far apart, due to which they occupy more surface area, more space. Now, on the basis of these postulates, we are gonna classify the electrons. So here, as we know that here, as you can see in the diagram, first step here involves the number of electron dense areas. Number of electron dense area over here are two. There are two hybrid orbitals, due to which they form a linear shape, linear structure. No lone pair is present over here. Now here in the second structure there is a trigonal planar structure, in which there's 120-degree angle, and a linear there's 180, due to which this trigonal structure. Alright, so it is a trigonal planar structure which is having its angle as 120-degree. But in case if it is having one of its hybrid orbital to be having a lone pair, then that would be having an angle which is less than 120-degree, and its shape will ultimately become as angular or V-shaped if there is a presence of this lone pair. But here, if there is no lone pair, then all of these hybrid orbitals will have trigonal planar shape. We have previously discussed the examples as well. What are the examples? Boron trifluoride, as well as we are having examples of boron trifluoride, phosphorus, trihydride, as well as astatine trihydride, antimony trihydride, and so on. Rest, when it comes to tetrahedral, we are also known about it, that their tetrahedral shape is determined by four hybridized orbitals. These four hybridized orbitals are arranged in such a manner that each is having 109.5 degree angle shape, and if they are having one lone pair, if they are having one lone pair, then that would be a trigonal pyramidal shape. It is a case in ammonia, um, as well as some other molecules as well, including silicon fluoride, trifluoride is a good example of it. Apart from which, silicon trifluoride is having good example of this. If there are two lone pairs, for suppose if there are two lone pairs, then that would be having a bond angle which would be further decreased. As we have previously discussed, this condition exists in water, hydrogen sulfide, as well as sulfur chloride, which is 104.5. Here trigonal pyramidal involves example of bond angle, which is 107.5. We have previously discussed it. Rest, when it comes to another part, we are having here the trigonal bipyramidal is the orbit is containing five hybrid orbit. It is containing four hybrid. I mean, like, there are the hybrid orbitals are in such a manner that there are five hybrid orbitals in such a manner that there is each hybrid orbital is combined by one s, one p, one px, one py, one pz, one s, and one d orbital. So in this case, this is s p 3 d hybrid orbital. sp3d hybrid orbital is a complete set, and here, as you can see, this is sp3 d hybrid orbital, which is trigonal by pyramidal hybrid orbital, trigonal by pyramidal shape, which is formed. Example of this includes phosphorus, uh, pentachloride, PCl5 is a formula, and here the bond angle is having examples. A bond angle is around 120. That is a varied bond angle, which means the structure is quite complicated to draw because it is a trigonal bipyramidal. So bond angle varies. Sometimes at some intervals it is 120. Between two pyramids it's 120, and between two triangles it's 90. Rest, when it comes to some shape, if there is one lone pair, then the shape will turn as a sawhorse shape, as you can see in the diagram. There's a sawhorse shape in which the lone pair is on one hand side, which causes to increase the repulsion between lone pair and bone pair, due to which this is a sawhorse shaped shape arranged. And then there is another example, if there are two lone pairs, if there are two lone pairs, then this is a T-shaped orbital. If there are two lone pairs, then that is a T-shaped orbital. As you can see in the diagram, this is looking like a T-shaped orbital. Rest, if there are three lone pairs, then that would be a linear structure. This kind of structure exists in hydrogen fluoride. In hydrogen fluoride, fluorine is having four hybridized orbitals. Three of the hybridized orbitals are having lone pairs. One of the hybridized orbital is having unpaired electron, bonding electron, unpaired electron, bonding electron, or used electron, which is supposed to be used in this process. Here in this case, as there are more lone pairs, these lone pairs cause to exert more force of repulsion, due to which the bonding electrons become linear or straight and thus form an angle of 180. Here octahedral is having an angle of around 90 degree. Octahedral is having an angle of around 90 degree, in which there are six hybridized orbitals, and six hybridized orbitals can be classified here in such a manner that here there is s, six hybridized orbital, sp3 d2. Now there are six sp3d2 hybrid orbitals, and this type of bond formation occurs in sulfur hexachloride. And in this case, if there is one lone pair, then that would be a square pyramidal. If there is one lone pair, then that would be a square pyramidal. Structure is quite complicated. There are multiple angles. And similarly, if there are two lone pairs, that would be a square planar. And if there are three lone pairs, then that would be a T-shaped structure. Three lone pairs, then that would be a T-shaped structure. If there are four lone pairs in octahedral geometry, then there would be a linear structure because four lone pairs exert a high amount of force of repulsion, due to which the bond pair becomes extremely linear and 180-degree angle is formed. That's all about today's video. Hopefully, we'll meet again in another.